Okay, the next section is chemical formulas, molecular and ionic substances. A chemical formula is a notation that uses the atomic symbols with numerical subscripts to convey the relative proportions of atoms' different substances. So in this example here, I have, this is called sodium sulfate. And so this subscript here means that I have 2 sodium atoms. There's nothing after the sulfur, so I have 1 sulfur atom, and I have 4 oxygen atoms. Now, occasionally, you will have a compound that has parentheses around it. Let me think of one like that. If I have CaOH2, that means there's 1 calcium, there are 2 oxygens, and when I'm writing it, I like to say OX because it looks like 20 otherwise, and 2 hydrogens. Because when I put the parentheses around it with the 2 outside, that means it's 1 times the 2 there and 1 times the 2 there. So if this was sulfates, for example, and I had parentheses around it with some number outside, then it would have been, let's say I had, just for fun, if I had a 3 here, which this compound isn't, that means I would have 3 sulfurs and 12 oxygens. Okay? Okay, a molecule is a definite group of atoms chemically bonded together. Now, we talked about compounds earlier, and it's a very small difference between what a molecule is and what a compound is. The molecule says that they're just atoms. They could be the same atoms, whereas a compound says they have to be different atoms or different elements. A molecular formula is the exact number of atoms in each molecule, and a structural formula is a representation of how those atoms are bonded together. So this one right here would be just the molecular formula here. Okay? It doesn't show how they're bonded together, but it shows all the atoms that are present. So this figure out of the textbook shows you, this is 3 different compounds, water, ammonia, and ethanol. So this is the molecular formula. I have 2 hydrogens and 1 oxygen. I have 1 nitrogen and 3 hydrogens. I have 2 carbons, 6 hydrogens, and 1 oxygen. This is the structural formula. Things that I can't do because of the fact I don't have computer generation. Here's what they call the ball and stick model, the space filling model, and the electrostatic map model. Okay, but basically they're all forms of the structural formula. And the book will give you problems typically in one of these 2. We will get into this much later, probably in 1212 actually. You have another class of molecules called polymers. Okay, polymers are a large number of molecules made up of smaller molecules linked together. So an image here is these would be the monomers. Okay, the smaller molecules that link together. So each one of these would be a monomer. I typically have to have some compound that will bring these together, and then these form together. Either they co-link and this makes a polymer, or sometimes this compound's incorporated into it, and that would be an example, or into these. These are all 3 different types of polymers. Now, polymer is a very generic name. A lot of what we have is polymers. They can be anything from plastic, synthetic, or plastic bottles, okay? And even those come in a wide variety, you know. You have the water bottles that tend to be very easy to crush versus soda bottles you cannot crush. You have wool and silk, which are natural polymers. You have nylon, like nylon hose, and you have Kelvar. And so it can be either very rigid or it can be very squishy, like a plastic bag. And those are all different types of polymers. So polymers is actually, if you're a chemistry major, is a course that you take here as a 1-semester course. So the next question 70 out of the textbook says, what is the molecular formula for the following structures? Okay. So A here, I have carbon, and I have 1, 2, 3 of those. Now, when you're answering this type of question, I'm not going to care what order the elements are in, okay? But these are typically the way that they're listed in most chemistry textbooks. Hydrogens, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 hydrogens on this one. And oxygens, I again have 1, 2, 3. So this is the molecular formula for this glycerol. Disilane, Okay, I'm going to start again with the center atom, Si, and I've got 2 of those. And hydrogens, and I've got 1, 2, 3, 4, 5, 6 of those. This is the molecular formula for disilane. Hydroxylamine, okay, I've got 1 nitrogen, I've got 1 oxygen, so I don't need to write the 1 down here, and I have 3 hydrogens. Okay, so that would be hydroxylamine. And sulfur tetrachloride, again, I start with a central atom, so sulfur, and I have 1 of those, and fluorides, I have 4 of those. Okay, so that's how you write the molecular formula from the structural formula. I typically won't ask you to do the reverse. I'm not going to give you this and ask you what the structural formula, because there's actually several different ways that this could go together. Now, for ionic compounds, they're made up of ions. An ion is simply an electrically charged particle from an atom by either adding electrons, which means they're negative, or removing electrons, which means that they're positive then. Okay? So an anion is a negatively charged electron, which means I've done what? I've added electrons here. So chloride atom that's neutral has 17 protons and 17 electrons. Okay? But when I make it a chloride with a negative charge and the ion, it goes from having 17 protons to 18 electrons. The number of neutrons are staying the same, so the protons. What I did is by having a 1 negative charge, I added a negative 1. For sodium, okay, it can have, sodium is element number 11. So a sodium atom has 11 protons and 11 neutrons. I lose 1 electron, so this one has 11 protons and only 10 electrons, whereas this one has 11 protons and 11 electrons. Okay, and that's a cation or a positively charged atom. And an ionic compound is when the positive ion, like sodium, and the negative ion come together. Okay. Ionic compounds typically don't form just one compound. They form what they call a crystal structure, and it's basically a formation of both ions, and it goes on for a very long time. So the formula unit is typically what we use for ionic compounds, and it basically just tells you that for every 1 sodium in this structure, I have 1 chloride in this structure. And it doesn't have to be 1 to 1. So the last question here is to take the pairs of ions and write the formula. So the whole idea is that I want this to be a neutral compound, which means the positive charge has to equal the negative charge. Now, you can sit there and kind of figure that out, but there's a trick to this, which is that I'm going to crisscross. I'll change my color of my ink here. I'm going to crisscross these, so the 2 comes this way and the 3 goes that way. So it's CO, and the 3 came down. I don't worry about the charge. And then N, and the 2 comes here. So what I ended up with is 3 times a plus 2 gives me a plus 6, and 2 times the minus 3 gives me a minus 6. And so the charges are equal, which is what has to happen for a compound. The next one is ammonium and with a plus 1 charge and phosphate. Again, the charges crisscross. Okay, these are what they call polyatomic ions. We'll get to that later this chapter, but they all go together, like the example of hydroxide I gave earlier. So if there's going to be 3 of them, there's going to be 3 of the whole thing, NH4. So I have to put a parentheses around it and indicate the fact that there's 3. I don't have to indicate anything for 1, it's understood, so it just is then PO4. Okay, so this also goes back to a little bit earlier. I have 3 nitrogens. I have 4 times 3, which is 12 hydrogens. I have 1 phosphorus, and I have 1 times 4, which is 4 oxygens. Okay, so when I have a parentheses, that 3 means that it's 3 of everything inside of this. Okay, another one is sodium. This is another polyatomic ion. I can tell because there's 2 elements present there, and it's an ion. So again, they crisscross. So that means I have sodium with a 2, and 1 I don't need to indicate, so therefore it just becomes SO4. And the last one's not actually in the book. I just made it up. If I have calcium and seleniate, with both having a 2+. Remember, the whole idea of this is that my charges end up being neutral. Okay? So with a +2 and a -2, it just simply becomes CaSeO. I don't know what's wrong with my computer, must be hesitating. SeSO4. Okay? So the whole idea is to get a neutral compound. So I had the +2 and the -2, which is neutral. Here I have 2 times the +1, which is a +2. This was a -2. This was 3 times the +1, and this was a -3. So that is neutral. So the whole idea when I combine ions is to get a neutral compound. And this is the end of this video.